Alright, so today I'm making a coding video solving sum of multi-dimensional arrays. This is a past favorite of mine, and I solved it not once, but a couple of times in the last couple of days, or at least similar problems to it. So it's kind of a tricky one for me, but I'm going to try to do it on the fly. I haven't memorized it or anything, but just having done it recently should give me a little bit of a head start on getting this one right. And right off the get-go, well, that shouldn't be there, but it is, so I guess that gives you a little bit of a hint as to how I will be solving it. So I'm going to be keeping track of the sum in the parameter and starting with the value of 0. It makes a lot of sense, right? Because this will be a recursive solution. Recursion's obviously not ideal from a performance standpoint, but it is the solution that I'll be using, and I just want to get some practice with recursion. Alright, so let's get started. First I'll explain the problem, although there's a couple comments here. Take an array of number values and return the sum, and the arrays can be multidimensional, obviously. So it's pretty easy to, or I should say it's an easier algorithm to simply loop through the one-dimensional array and return the sum. In this case it should be 12, but what if the arrays were multi-dimensional, meaning they're arrays within arrays? So this would be the outer array here that I'm highlighting, but within it there's one value which is on its own, but then there's an array of an array. So the 2 and the array of 3 are in an array and are one value within the outer array. Then there's simply an array of 4, so that's two-dimensional. And then there is another array that has a 5 and a 6. So this is a two-dimensional array as far as I can tell. Nope, it's actually three-dimensional because the 3 is an array here. But I have one more, slightly more complex example here. They don't go any deeper than 3, but I assure you they will keep working no matter how deep it goes. And you'll see why in a second. Hopefully I'll explain it to you in a way that makes a lot of sense. So the first thing we're going to do is we're going to, since this is a recursive solution, we do need a base case. So the base case in this case is going to be, so already I cannot remember the base case or anything close to what it's supposed to be other than it's an if statement, which almost all of them are. So let's see. If array.length is less than or equal to, I like to do less than or equal to just because it captures not only the 0 but all negative numbers, and I just feel like it's more foolproof. It's also less keystrokes, so there is that. And this should return sum. Obviously we're going to be building up the sum, so the ultimate goal is to return the sum. That makes sense to me. Alright, so that is our base case for now. I may modify it as we proceed. So let's see now. Here I'm going to go into a loop, and I'm going to loop through all the values in the array. That just makes sense to me. So let I0 I is less than array dot length. Just going to do a very traditional for loop here. And what are we checking? So this is where I need to explain the method I'll be using for checking whether the value is a number or an array of numbers in this case. The summary is that in this for loop, on line 9 through 11 so far, obviously it'll grow. It'll handle, if it's a regular number, add it to the sum. If it's an array, which is the only other possibility, so we can do else. If it's an array, then recursively call itself, and when it calls that, then if it still sees that there's another array, it'll recursively call itself again. And it'll keep doing that as necessary until it reaches a raw value, which then will be added to sum. And after all of those recursions are done, and every value is calculated into the sum, then it'll reach the bottom where it will return a value. So that's the plan, and it should work, and I'll just code it up so that you can see how it works. So the first thing I said is that we will check I'm actually not so sure I need to do a traditional for loop, so I'll update that. to a for of loop if I find I don't need the easy access to the index values. So that being said, so first thing we'll do is we'll use this array method called array.isArray. And I could show it to you in MDN, I suppose, real briefly. So array.isArray MDN. And let me just bring it up here so you guys can see it. So just temporarily, if kind of accidentally full screened it there, but it will serve the purpose just fine. So the syntax is array is array and the value to be tested. So, you know, usually you'd pass in a something like a variable instead of blatantly obvious passing in an array, but it proves the point. If it's an array, it'll be true. If it's anything else, including an object, it'll return false. So it's better than using type of object, which will also return true for objects, not only arrays, which will also return as objects in the type of checker. So it's just more precise to use array.isArray, although in this case with this function we know that all the inputs are going to be array of arrays, so we could just use type of and look for object, but this is just more precise, more purposeful for exactly the purpose of checking for arrays and not arrays or objects, which are both objects, but you get my point. It's distinguishing that it's an array specifically. So it's good to know for whenever you need to handle arrays specifically and be able to differentiate between arrays and objects. So that's kind of what we're going to be using. And we're going to be checking if array.isArray, and we're going to be using array at I. So we're checking each value of the array because we're using a for loop. It'll be array at I. And if it is an array, so this is when it needs to recursively call itself. I'm just going to put pseudocode there for now. Recursively call itself. And else. So this is when it's just a number, basically, if it's not an array. So this one's easy. It's going to be sum, oops, this equals array at I. Ah, yeah, these brackets are for the array method, but I never actually closed it. So it needs an extra to close the if statement. I was only closing the argument being passed in. All right, so now everything is fine. Boy, syntax highlighting is great for finding stuff like that. So I can see why it's done. Okay. So yeah, that's the easy part, the else. And for here, we have to do sum equals sum of multidimensional arrays. And what do we pass in? We're passing in array at I, which is an array. We're establishing that by checking in the if condition. So if array.isArray of array at I is yet another array, I could probably clean that up once I use a for of loop because it's looking increasingly like I can just, in fact, let me just change it all into a for of loop. Then sum plus equal, it's just equals in this case because it'll be doing operations inside the recursion. Let's put a semicolon for consistency and let's update this to element. So if it reaches the else statement, then the element is a number, and so we just add it to the sum. If it hits this if statement, then it's an array, and so we need to handle it by passing it in as an argument to some multidimensional arrays. And we also need to pass in the sum up to that point. So we'll pass in sum. All right, and let's see what else we need here. So let's just talk this through using line 19 example, just, you know, the first few stages. So we'll go through this. Array.length will be longer than 0. Oh yeah, we have to approach our array condition. So how can we do that? Yeah, I don't feel like this is the base case we need. Let me just talk myself through this. But so yeah, the first thing that's going to happen in the line 19 example is 1. So, you know, let's ignore the base case for the time being, and maybe we'll figure out what we need to modify it to. So const element of array, that's just a for of loop. I won't go into it, but if you guys want to find out how that works, it's great. Look it up on MDN. What can I say? So array.isArray I explained, and so we're checking, and the first number will just simply be added to the sum. So we'll go to 2, 3, well 2 and array of 3. That will trigger the if statement because it's in a for loop. So we're already past this. We're never going to go back to it at the top level. Sum of multidimensional arrays, we're passing in now this array. Exactly what I've highlighted, which is the 2 and the array of 3 contained within an array. So the length of this array is 2, but 1 is a number, 1 is an array, which contains a single number. All right. So it calls recursively. Yeah, I think the recursion makes sense, because as long as it's an array, so once it reaches 2, then the 2 is added to the sum, but that's not good enough. It needs to return. So I think I need a return statement, and I think I need it to be outside the loop. Return sum. Okay, so that'll bring it out from any recursion instance, and also from the final iteration. All right, so as crazy as this sounds, I feel like I don't need lines 5 through 7, which is the base case, and I'm just really surprised that I feel like this will run without lines 5 through 7. I'm just gonna try it, and I feel like I'm gonna go into an endless loop because I don't recall ever getting a solution where I don't need a base case, but goes through a for loop. There is a return statement, so you know, eventually once it reaches a number, adds to the sum and returns sum, which then comes back out and returns that sum, which then comes back out. I'm just gonna try running this. Okay, so something doesn't work. What is it? Oh, that's just blatant mistake element. But what else? My goodness, it works. All right, so I am really surprised, genuinely surprised. Like I said, I did not rehearse this, but I did do this problem or a similar problem a couple of times in the past couple of days. And there's no base case. And there is recursion, because it does call itself. So what is the base case here? Because there has to be a base case, right? In this case, the base case is when we've finished looping through the outermost array, then return the sum. So yeah, it's not the traditional form of the base case that is usually taught, which is if some condition is met, return, and you know, there'll be some code within the rest of the function that makes the recursion get closer and closer to the base case. But in this case, our base case is finishing looping through the outer function. And we recurse only when it's inside that loop and needs to handle the array type of data rather than just the number. Then it recurses itself to handle that and then returns that sum to the outside So then it can extract it from the recursion and ultimately add it to the sum. I don't know if that made sense, but yeah, so this works. That's the base case, and that's the problem. I think it's a really cool problem, and there are variations of this. For example, you know, instead of getting sums, you can have all sorts of data within the array of arrays, and you might need to do something different with them. For example, you could even do callbacks. You know, you could do every and just need access to all those data points inside the arrays. Let's say you wanted to check if every value inside the array would return true when you run a callback on it. Then you can modify this. I'm not going to do it right now, but you can modify this. So knowing how to do this is useful and can be applied to more complicated functions. Binary trees, for example, might be a small hint. The other thing that we should note is, at least in CodeSmith, we've been doing regular functions recursively, but it should be noted that anything that can be done recursively can also be done without recursion. And it is usually, in fact, I think always, or if not almost always, more performant to not use recursion. So it might be a good idea to practice being able to do something like this without recursion. So there's a challenge for you. Now that you've seen this solution, see if you can do the same problem, but without using recursion, without calling itself inside. And there is a way to do it, but it will be tricky if you've never done it before. All right.